Many people say poker is all luck. Others say it's a game of skill. Where is the truth, and is it possible to win at poker in the long run? We're going to find out in today's lecture about variance and bankroll management. Let's talk about variance and bankroll management. Easily one of the most underrated things in all of poker. Variance and bankroll management is not a sexy topic, right? And the truth is that most of the advice you find online are just rules of thumb. They're just kind of guesstimates, but there does exist mathematically optimal strategies for growing your bankroll as fast as possible. I'm going to present some of those strategies to you today. Now, this is kind of a touchy topic. People have different risk profiles, but I think it's important to manage risk, not just in poker, but in the shots you take, in what stakes you play, in how fast you want to move up. These are key to your long-term poker success. Poker is a game of small edges, and managing risk is key to success. Not only that, but understanding the nature of variance, being able to conceptualize how swingy this game is, will help you control and manage tilt. So I truly believe that variance and bankroll management are one of the most important yet underrated topics in poker. I really wanted to put this lecture out there so that everyone will have some free resources to optimize their bankroll management. We're going to talk about three key topics in this lecture. One is going to be, is poker luck or skill? We're going to talk about understanding variance, and that's going to involve, what is variance? How do you use a poker variance calculator? How to understand risk of ruin profiles. And lastly, we're going to look at how to optimize bankroll management. Let's start with this question. Is poker luck or skill? Well, you're poker players, right? If it was all luck, why would you even be playing? Just go play slots, right? Buy a lottery ticket. So the truth is that it's both. It's not 100% skill. It's not 100% luck. Poker is luck and skill. And how much luck or skill it is depends on your timeline, depends on how many hands you play. It depends on the sample size. Now, when we look at it from the point of your timeline, tiny edges get magnified in the long run. What does that mean? Let's say you have some small edge against your competition. In the short term, your results will be mostly dominated by luck. In the long term, your results are more dominated by skill. And over an infinite timeline, an infinite number of hands played, poker becomes 100% skill. Now, I'm going to talk a little bit more about how this works in Chapter 2. Now, poker is a combination of both, and the truth is you need to ride out the variance. And learning to do that correctly, learning to only risk what your bankroll can manage is key, right? And this isn't the only thing like that. Other examples include trading stocks or options, investing in a business, counting cards at blackjack. Almost every financial pursuit involves some combination of luck and skill. So thinking in black and white that it's one or the other is, of course, a fallacy. It all comes down to your timeline. So let's talk about understanding variance. Now, some key concepts for this section. What is variance? What is the law of large numbers? How do we use a poker variance calculator? And what on earth is a confidence interval? Now, these are all very mathematical sounding words, and we've got some fancy looking graphs here. But the truth is that variance is a pretty straightforward topic when you really think about it. When we ask ourselves, what is variance? We get this scary looking graph with numbers and sigmas. The term variance refers mathematically to a statistical measurement of the spread between numbers in a data set. So how spread apart are your numbers? More specifically, variance measures how far each number in the set is from the mean. So if you're getting really swingy results, that's high variance. If most of your results are clumped towards the middle, that's lower variance. In poker, variance simply refers to how swingy your results are. Again, we're talking about how far away your results are from the average. So if we could imagine that there's some true win rate here, someone with high variance would experience extreme swings, where someone with low variance would have their results closer to their true win rate. Now, why is this important? Because the swingier your results, the more you need to account for things like risk of ruin. You need to be taking on less risk proportional to your bankroll. So let's try and visualize this. This is just a clip taken from my favorite poker variance calculator, Prime Dope. This is a low variance. This is 50 big blinds per 100 with a win rate of 5 BB per 100. And let's compare that to high variance. Now, maybe it doesn't stick out to you, but I want you to pay attention to the axis on the left and right. In this one here, given 20 samples, the best result was like 22,000 and the worst result was like negative 17,000. Previously, the best result was about 10,000 and the worst result was about minus 1,000. So we go from minus 1 to plus 10 to minus 17 to plus almost 20. So you can see that despite both of these players having the same win rate, one is experiencing much higher variance than the other. Their results are more swingy. Maybe they're a bit of a maniac. Maybe you can see yourself a little bit in this. Are you the nitty type who only bets with an edge? Are you more of the big risk taker type? Both results have the same expected value in the long run, but the higher variance approach carries some other risk to it, right? So let's talk about the law of large numbers before we dive into that data a bit more. And this is like the simplest exercise that I think many people do not understand. Most of you will have heard of the gambler's fallacy. I'm sure you guys being even participating in this lecture will have heard of this and will know about it, but you may not apply it properly when it comes to your bankroll. So let's say we flip a fair coin and it lands on heads 6 times in a row. What is the probability that it lands on heads in the next flip? The truth is, yes, the expected value is that heads retains its 6-point lead, but it doesn't matter because your probability is 50% on the next flip. Let's take a look. Let's give heads a 6-point lead and flip the coin 1,000 times. The expected value in this case is going to be heads 503 times and tails 497. So the EV starting with a 6-point lead is that heads retains its 6-point lead, but it still converges to 50-50. You can imagine if we do it 10,000 times, now it's 50.03 and 49 point, it just gets closer and closer to 50-50, despite the fact that tails never actually catches up from that 6-point lead. Now, of course, it can catch up. Of course, anything can happen, but the expected value doesn't actually change. Now, what does this mean? When we think about, for example, if you've hit some run bat, right? You're down, your all-in EV is down maybe, I don't know, 10 buy-ins from where it should be, right? Do the poker gods therefore owe you that 10 buy-ins back? Are you now due for a 10 buy-in upswing? The answer is no, right? The answer is no. If you are starting with a 10 buy-in downswing relative to where you should be, the expected value is to keep going with that 10 buy-in downswing, but over the long term, it won't matter because over a large enough timeline and enough hands, you're going to converge closer and closer, despite the fact that there is no universal karma that's going to catch you up. So let's talk a little bit about risk profile. How much risk can you handle? Now, us being poker players, we naturally, this demographic has a high risk tolerance. Why else are you playing poker, right? Poker naturally attracts people with a high risk tolerance. But the truth is that the optimal amount of risk for you depends on your lifestyle. Is poker your only source of income? Do you have other income streams? Can you afford to bust? Is it important to grow as fast as possible or make a reliable profit and pay your bills, right? So the truth is that the amount of risk you can take depends on your situations. There is no one size fits all. Despite that, I'm going to show you some mathematically optimal bankroll strategies that try and help you maximize your risk reward. We've talked a little bit about how much risk can you handle. What I want to show you next is one of the most important topics I can show you here, and that is how to use a poker variance calculator. So if you learn nothing from this lecture, learn how to use this tool, okay? This one is by Prime Dope. Others exist. This is a free tool you can find online that helps you find your variance. So this is the way it works. we have 4 fields we plug in here. One is the win rate. So let's plug in, for example, you win 5 big blinds per 100. The next is your observed win rate. Let's just leave that blank for now. The next is your standard deviation. Now in cash games, 6-max cash games, it's about 100, but it depends where you play, right? If you play PLO, it's going to be much higher. If you play heads up, this is going to be much higher. If you play full ring, it's going to be much lower. So your standard deviation in big blinds per 100 is something you can find with any HUD. It's a stat you can pull if you don't know, but you can use 100 as default thing here. So let's go ahead and calculate that. So we win 5 big blinds per 100 and we play 100,000 hands. Here we see 20 samples. That is to say, just 20 random samples given this edge. And we can see that some of the samples ran like a god and others ran terribly, right? And if we look at the variance in numbers, we can ask ourselves, what is the expected value? We typed it in, 5 big blinds per 100, standard deviation, number of hands, expected winning after 100,000 hands is 5,000 big blinds. Standard deviation is how much, give or take, you should win. So it's $5,000 plus or minus this amount in one standard deviation. And this is a great tool because it helps you visualize what you should expect to win. So here we can see a 70% confidence interval. I'm going to talk a little bit more about confidence intervals later, but essentially, if we assume your true win rate is 5 big blinds per 100, then over the course of 100,000 hands, you should expect to win somewhere between 1,800 big blinds to 8,100. And if you want an even more certain interval, that is to say, we are 95% sure our results will land between these two numbers, that's what you'll get, right? So a really confident interval is going to be a wider spread. But most of the time, your results are going to be somewhere in the middle here, right? Somewhere close to the expected value. Now, of course, we can increase the standard deviation. So if we put that up to 200, we're going to see it's much more spread out. And if we put that down to 50, we're going to see it's much closer together, closer to the mean, right? So a lot of players ask, what is a good sample size? How do I know if I'm a winning player? Well, this is the tool you need to do it with, right? Let's imagine that you play 10,000 hands, right? What are the chances that you lose money despite being a winning player after 10,000 hands? If we scroll down here, we can see the probability of a loss after 10K hands is about 30%, right? About a 30% chance that you're going to lose money despite being a winning player, playing a winning strategy after 10K hands, just due to pure luck. However, if we put that up to even more hands, let's make that 50K. The chance that you lose money goes down even further after 50K, right? After 100K, now it's down to only 5%. And to some, this might sound crazy. Like you're telling me there's a 5.7% chance I lose money despite being a solid winner after 100,000 hands. And yes, there is. There's also an equally likely chance that you run like a god, right? So let's say, for example, that your true win, you are a break-even player, and you want to ask yourself, what are the chances that I'm actually a crusher who's supposed to be winning at 10 big blinds per 100? Actually, we'll do this the other way. We're going to go 10 and 0. So, and let's do 10,000 hands. So you observe your win rate is 0, and you think your actual win rate is 10. What are the chances that you are a 10 big blind per 100 crusher despite being a break-even player after 10K hands? And here, again, we can see this, and we can see probability of running at or above observed win rate over 10K hands with a true win rate of this much. So there's a 15% chance that you, a break-even player, are actually a 10 big blind per 100 crusher after 10,000 hands. After 100,000 hands, it gets even smaller. So after 100,000 hands, if you're break-even and you think you're a 10 big blind per 100 winner, well, that might be true less than 1% of the time. But for the most part, no. So this is a really useful tool to visualize variance in poker. And as we can see, poker is very swingy. There's variance is larger than your mind can imagine, right? There's also a thing here that has to do with downswings. So that is to say, what kind of downswings can you expect? And the truth is that every poker player, if you play for a long enough timeline, you will experience ungodly downswings and also run like a god, equally probable, right? And you need to be prepared for that. Now, there is a human axis that this chart does not simulate, and that is that when players are running badly, they tend to change their strategy, they tend to increase their variance, and they tend to magnify their own losses. That is to say, when you're running like crap, you tend to change your strategy to run even worse and take on even more risk. It's just a natural human response. And it's really important to control that response if you ever want to achieve long-term success. Imagine you're running well, and then you go on like a 2,600 big blind downswing, right? You're going to be devastated naturally. Like, how am I running this badly compared to EV? But if you don't grind through that properly, if you don't continue to play a solid game, then this loss can be orders of magnitude larger than it appears here, because you're going to change your strategy to play much worse. So controlling tilt in times of hardship is also key to managing your risk. Confidence intervals are key to understanding statistics and any measurement where the measurement is uncertain, right? So this is a distribution. This is just a normal distribution. So we can say that, imagine that your win rate is somewhere from left to right. Don't worry about the exact axis here. We're going to say that within one standard deviation, that is to say, one standard deviation, i.e. 2/3 of the time, your actual results will fall within this range, given that this is your true win rate. So if your true win rate is here, the mean, your actual results within one standard deviation will fall somewhere between here and here. Within 2 standard deviations, it falls between here and here. So 2 standard deviations mean 95% of the time, your true results will fall within this range, given that this is your actual win rate, right? You can never be certain what your true win rate is. All you can do is assign a confidence interval and say, I am 95% confident my win rate is between here, and this is the mean. That is the way you express certainty mathematically and correctly. So you can never be certain, but you can play more and more hands until this confidence interval shrinks and you get more and more confidence that your mean here is the true result. That's a confusing concept to many if you haven't studied math or statistics, but it's easier than it sounds. So for example, let's have one here. We observe a win rate of 2.5 big blinds per 100. We play 100,000 hands. What that actually means is that our true win rate within one standard deviation, within 70% confidence, is going to be between negative 0.66 big blinds per 100 and 5.66. If we want to be more confident, if we want to assign a 2 sigma confidence interval, your true win rate is between minus 3.8 and 8.82. And as you play more and more hands, that confidence interval will shrink down until you get more and more confident results relative to your actual results. So understanding and thinking in confidence intervals is key to determining, am I running bad? Am I unlucky or just bad? Or am I a god or just, super lucky? So realistically, if you want to understand the way luck and skill interact, you need to learn how to use confidence intervals and poker variance calculators. And hopefully I've given you guys the tools to get started estimating your results using these types of tools. I'm going to go on here because there's a number of other cool subjects I want to show you guys before this lecture ends. So this one will be quick. How to use a risk of ruin calculator. This one is a very old school calculator based on some old 2+2 Mason Malmuth math. So let's assign some win rates and some standard deviation. And let's say that we are playing with one bankroll. It can never be refilled, topped up. You just play with this edge and this much money until you either win or lose. So we'll assign ourselves a 5% risk of ruin. And that means that there's a 5% chance that we go bust. In order to achieve that, we need our bankroll to be about 3,000 big blinds, right? So about 30 buy-ins. And that's going to give you a 5% chance of losing all of your money. This assumes there's no moving up and down. It's a very simple calculator, right? Now, let's assume that you are willing to take on a lot more risk. You know, I'm willing to deal with a 25% chance of busting forever. Well, in that case, you only need about 13, 14 buy-ins, but you better be a winner. You better have this standard deviation, because if this is a little higher and this is a little bit lower, well, all of a sudden, your risk of ruin just went from 25% to 50%, right? So that's why most people suggest a much larger bankroll. They suggest something like 100, roughly 50 to 100 buy-ins. So here we can see that with a slightly lower win rate and a slightly higher standard deviation, you know, maybe I'll pump that up to 130 this time. You can see that just to have a 5% chance of not going broke, you need an 84 buy-in bankroll, right? Now, I won't get too much into the math here. There are references down below, and I've also built a calculator that will calculate this out for you. But it's important to realize that the amount, how big your bankroll should be, is a function of your win rate and your standard deviation and how much risk you can tolerate. A pro player needs to take on much less risk. Like if this is all the money you have in the world, well, you better be playing stakes that aren't going to bust you. So important to account for your risk of ruin, regardless of whether you're playing cash or tournaments or MTTs or anything else.